Here is a video showing you how to use the TI graphing calculator to solve exponential equations. So recall, an exponential equation is an equation that involves an exponential expression, which simply means that the variable is located in the exponent. And so let's jump into an example where we're going to just use the graphing calculator to solve this. So example 1. The population in a certain city was 53,000 in the year 2000, and its future size was predicted to follow P of t equals 53,000 times e raised to the 0.015 t power, where t is the number of years after 2000. When did the population reach 60,000 according to this model? So first thing I'm going to do is I'm going to write our equation that models the population of a certain city. And so notice here, this is an exponential because notice the variable t is in the exponent. And so whenever I'm doing applications, I always write down my two variables. I have my input, which is t, and my output is p of t, right? T represents the number of years after 2000. And P of t represents the population in a certain city. So the question is, when did the population reach 60,000 according to this model? So you have to decide, what does this 60,000 represent? Well, it represents the population of a certain city. So that means that 60,000 is P, right? So you're going to replace your output, P of t, with 60,000 in the equation. And you're going to try to solve for t. So you can solve these algebraically, and that is totally fine, or you can solve them graphically. So to solve them graphically, we're going to use the intersection method. And so the 60,000, the left side of the equal sign, I'm going to put in y1. And this exponential expression, I'm going to put y2. So I'm going to go over to y equals, and I'm going to clear out what I have there already, and I'm going to put in my 60,000. And I'm going to put in 53,000. Then that's going to be e. So you have your e raised to the x power here, so press second, and then your natural log. And then typing in 0.015. And then, yes, this is t, but we're just going to use x here. And I'm going to go ahead and graph this. So the window settings are set to something different from a previous problem. But what you want to focus on is that this 60,000 is a horizontal line. So you have to move your y-axis up pretty far up to catch that 60,000. And so I'm going to go to my window settings, and this is where it kind of takes a little trial and error. I'm going to change my x min. I'm going to leave it at -10, and I'm going to leave my x max at 150. And I'm going to leave my scale at 50. Okay. My y min, however, I'm going to put it 0. Oops. Let's see. I'm going to leave that at -10. My y min, I'm going to leave at, so my y min, I'm going to put it 0. My y max, I'm going to have to include the 60,000. So I'm going to go up to, let's say, 75,000. And then my scale, I'm not going to leave it at 1 because this is a very large number. So I'm going to do, let's say, 10,000. You could do something different. That's fine. As long as you can see that intersection point, that's your goal. And there we go. We see it. So now we can calculate the intersection point. So press second and trace, go down to option 5, press the number 5. And then you want to get close to that intersection point. So press the left or right arrow only, not the up and down. Okay, press enter. Second curve, press enter again. And then press enter one more time. And so our value for t is 8.3, right? So in these types of problems, they're going to typically tell you to round to the nearest whole number. So that would be 8, okay? But the question wants to know when the population will reach 60,000. Well, t represents the number of years after 2000. So 8 years after 2000, we're in the year 2008, okay? So in the year 2008, the population will reach 60,000. And that's according to this model here. So that answers our question in the year 2008. Okay. So let's look at another example. Example 2, solve round to 3 decimal places. So once again, this is an exponential equation. We have 8,900 is equal to e raised to the 5x power. Okay. So we're going to use the intersection method. So under y1, we're going to put the left side of the equation, whatever's to the left of the equal sign, so 8,900. And on the right side, we're going to put e raised to the 5x. So e, there's 2 ways to use the e button. You can press second E here, press the division symbol, and then press the caret and type in your exponent, 5x. Okay, or you can press second and press this button here for e raised to the x power. Both of them get you the same thing. And so then we're going to go ahead and graph it. So remember, our window settings on the last one were at 60,000 or 75,000 is what we used. This only goes up to 8,900. So we're going to definitely want to change our window settings to kind of get a better picture of this graph. So I'm going to go ahead and leave my X alone and see what that gets me. I'm going to just change my Y. So instead of going up to 75,000, I'm just going to do like 10,000, a little bit higher than the 8,900. And instead of having a scale of 10,000, I'm going to bump that down to, let's say, 1,000 and see if this gets me a better picture. Well, I can kind of see this is the horizontal line at 8,900, and kind of see something here with that exponential graph. So I'm going to go ahead and change my X scale just to, not make it so large so I can maybe get a better picture here. So -10, and instead of 150, let's do like 25. And then change our scale to 5, okay? Like I said, this is trial and error. The window settings is typically the hardest part on solving these equations graphically. And there we go. I have a better picture. I can clearly see, here's my exponential shooting up. Here is my horizontal line. Here's the intersection point. So I'm going to go ahead and press second, trace. I'm going to go down, press the number 5 to use that intersect button, and I'm going to go over to the intersection point, press enter again, and press enter one more time. And so I get an approximation here. X is equal to 1.819 because we want to round to 3 decimal places. So here is our approximation. The calculator only gives you approximations. So if the homework asks for an exact answer, you may have to solve it algebraically. So it really is best to kind of know both ways. A lot of times they ask for rounded answers. That's when the graphing calculator is definitely perfect to use. So let's look at one last example. Here we have 5 raised to the x minus 2 power equals 11.18. Okay, so I'm going to go ahead and on the left, this is the left side, 5 raised to the x minus 2 power. So 5, let me clear this out, 5, and use the little caret here for the exponent, and then x minus 2 power. Okay, so notice my calculator, it automatically puts everything in the exponent. If your calculator does not do that and it shows you like this, you're going to need to put a parentheses around the exponent so that the calculator graphs it correctly. If you don't put the parentheses, if you have an older calculator, see how mine, everything here is in the exponent, so you don't need the parentheses. But if you're not sure, you can always just put the parentheses, okay? And then going to the second one, we're going to put in 11.18. Oops, and I forgot to delete some stuff. So let me delete the 5x, or let me just clear this all out because it's not cooperating. So we have 11.18. And I'm going to go ahead and graph this. And remember, last time my window settings were really high. And this is only 11.18. So I'm going to change that y-axis. We need to see 11.18. My y-max is now set at 10,000, so it does not need to be that high. Let's try 20. And my y scale, so for my y min 0 to 20, and my scale, let's do, I don't know, 2. Leave my x alone, see what happens, and there we go. We see the intersection point. So press second, trace, go down to option 5, press enter. So first curve, let's see where my cursor's at. So my cursor is way at the top. I need to come down a little bit, so there we go. A little bit closer to that intersection point. Press enter, enter, and enter again. And so rounding to 3 decimal places, we end up with 3.500 is our approximation. And once again, sometimes if they ask for exact answers, you may have to solve algebraically because the calculator gives a decimal answer, an approximation for these solutions. So that is it for this video showing you how to graphically solve exponential equations.